Okay, let's start again. First, let's introduce this lead-acid battery. This is the oldest battery. Uh, Basically, this battery is invented from the 1900s. From 1900, about more than 100 years early before. Okay, for this kind of battery, the negative plate is lead, and for the positive plate is lead dioxide. And after discharged, all the negative and positive plate they will become lead sulfate. Okay. Um, of course, if you recharge the battery, then it will become back to the lead and the lead dioxide. For this kind of battery, you have to notice that the cell voltage is only 2.05 volt. You have to notice this. Why? You know, for the decomposition of water, okay, for the decomposition of water, the voltage level is only 1.23 volt. That means the voltage level of the lead acid battery actually is higher than the decomposition of the water. And unfortunately, there is water inside the electrolyte. The electrolyte itself is a sulfuric acid and water because it is diluted sulfuric acid. So there is a large amount of water inside the electrolyte. So under the operation of the battery, the decomposition of the water is undergoing. That means the water will become hydrogen and oxygen, and it will leak, and we will be leaked into the air. And the water is gradually reduced. So this is the nature of this kind of battery. And you know, for the cell, the voltage level is only 2 volt. And usually you use this kind of battery in your experience, it's like 12 volt, right? In your motorcycle or your car, the voltage level is 12. Why 12? Because there are 6 cells inside. So totally it's 12 volt. You can see these are plates. Okay, these are plates. And this is called a flooded lead acid battery because the water can be flooded out of the battery, and there are some vent here. Okay, as I said, the water is decomposed into oxygen and hydrogen, and they will leak out from these vents. And meanwhile, you can also use this opening to replenish water into the battery. Because the water level will be reduced, so you have to replenish the water into the battery. Okay, so sometimes we call this kind of battery, this kind of battery needs some maintenance. The maintenance is to replenish water into the battery. Okay. And there are different kinds of lead acid battery, like this one. This is a sealed type. This is a sealed type. That means all the battery plates are enclosed in a sealed, airtight sealed container. Okay, so in the container, basically the electrolyte or the gas means the hydrogen or the steam or the oxygen, they will not be leaked out of the battery. However, you will think, if the decomposition of water is undergoing, then the air pressure may be higher, become higher and higher because the air inside is larger. So there should be the relief valve here. There is a relief valve. That means if the air pressure inside the battery is too high, then the valve will be pushed open to release the too much gas. Okay. However, this kind of battery, basically the chemical reaction is exactly the same as the flooded type, but in this kind of battery, there will be equipped with some catalyst. There will be some catalyst. The catalyst will help recomposition of the oxygen and hydrogen back into water. So in this kind of battery, the decomposition of the hydrogen and oxygen will become back to the water. So the gas generated will be reduced for this kind of sealed lead acid battery. Okay, and when we charge the lead acid battery, okay, we usually use a constant current. Okay, this is constant current, and when it reaches a certain voltage level, it will be switched to constant voltage charge. Okay, this is constant voltage. When it is under constant voltage charge, the charging current gradually reduced, and until some current level, the charge is completed. And here, you have to notice here, for the lead acid battery, after the battery is completely recharged, it can be switched into the float charging mode. Okay, there is a float charging mode for the lead acid battery. Even though the battery is fully charged, it can be float charged. That means your charger can be attached on the battery and continuously charge the battery. That is float charging. Then we will compare with other kind of battery about this point. Okay, and this is then we will discuss some characteristics of the batteries itself. Although we are talking about the lead acid battery, but the characteristic actually can be valid for other kinds of batteries. Here we want to talk about if we use a 0.05 C to discharge a battery. Okay, we can expect because the discharging rate actually is very small, 0.05. That means 1/20th, right? So we expect the discharge can last for 20 hours. Okay, because the C rate is only 1/20th, so it discharged to 20 hours. Okay, then if we discharge with 0.1 C, then we expect the discharging time will last for 10 hours, right? But you can see for the 0.1 C, the discharging time is less than 1 hour. Then if we use 0.2 C, we expect 5 hours, but less than 5 hours. If you use even larger C rate, like 3 C here, for 3 C, we expect the discharging will last for 20 minutes, right? But you can see maybe less than 6 minutes. Okay, so we cannot just expect we use a higher C rate to discharge a battery, then we can get the same amount of charge out of the battery. No, if we use a higher C rate, then we can extract less charge from the battery. Okay, and this can be represented by this Peuker's law. Peuker's law is an empirical law. Is a law just from the experience. And here you see the I is the discharging current, T is the discharging time, and N is some factor, and N is larger than 1. Okay, so you can expect if the current level is higher, the discharging time is even shorter. Okay, the C here is a constant. Okay, I said this characteristics actually is valid for other kinds of battery. So if you discharge the battery with higher C rate, then shorter discharging time. Okay. And then the the temperature and the capacity. If you operate your battery at a higher temperature, then you can discharge higher capacity out of your battery. At a higher temperature is fine. At a very low temperature, actually it's not good for the operation of your battery. Okay, for lead acid battery, I think it's very apparent. You can understand why. Because the electrolyte is, most of the electrolyte is water, and the water will be frozen at 0 degree temperature. You cannot expect a frozen electrolyte can be mobile for the ions to move in the electrolyte. So under low temperature, it is not good for your discharge or charge of your battery. Okay, so you can see the capacity ratio at a lower temperature is lower. However, we cannot say a higher temperature is better for your battery. Yes, higher temperature is better for you to extract the charge from the battery, but higher temperature also is harmful for the cycle life of your battery. So we also have to avoid the too high temperature. Okay, so the optimal temperature, the environment temperature for your battery may be around the room temperature and 250 degrees. For different kinds of battery, maybe the temperature is higher or lower. So, but usually you have to operate your battery within the range. That is better for your battery cycle life and your capacity. And then we'll talk about the cycle life. Here we can see it uses the discharge depth. Formally, it is called depth of discharge, or called the DOD. Okay, and the DOD can be defined as 1 minus the SOC. So if the battery is fully charged, the SOC is 100%, then we can say that the DOD is 0%. Contrary, if the SOC is 0%, then the depth of discharge is 100%. Okay, so here, if it is not clearly declared, then the DOD means we discharge your battery from 100% SOC to some certain level. For example, now the DOD is 30%. That means the discharge is from 100% to 70% SOC. Okay. Okay. So here, if the DOD is only 30%, then the cycle life is longer, like more than 1,000 cycle here. And if the DOD is 50%, then it reduced to 400 to 600 cycle life. And if even higher, then it is even shorter. So the depth of discharge, if you can reduce the depth of discharge, then the cycle life can be extended for your battery. And these characteristics is also valid for other kinds of batteries. You can also notice some unusual points here. Usually we will say initially the capacity of the battery is the highest, the new one is highest, but in our experiment we also noticed the phenomenon here. For the new battery, if we start to discharge the battery, then the capacity will become higher. So the SOH will be higher than 100% at the first few cycles, and then it decreases. And the reason we think we expect the reason is like, you know, for a new battery, the manufacturer they produce a battery, they produce a plate, the positive plate, the negative plate, and they fill the electrolyte into the battery. Then one process have to be undergo. What is that? There is one process called formation. For the battery manufacturing, there is one process called formation. The formation actually is to charge and discharge the battery with some profile. With some profile means with some specific current level and a specific time period. They have to charge and discharge the battery. Then the next process is called formation. After formation, then we can use the battery. Okay, but for the manufacturers, if they take a lot of time on the formation, then that means they need a lot of places. They need a factory, and the factory they have to store many batteries, and they are under the formation process. So if the formation process take too long time, they need no more places for the batteries. So usually the formation process is not fully carried out. So when we get the new batteries, at the first few cycles, we can observe that the SOH increases, and then it becomes normal. It becomes decreases. Okay, this is a phenomenon. And for the lead acid battery, there is one measurement factor for the batteries. This is called cold cranking amps. The cold cranking amps, this is a test criteria. The battery is discharged, and the unit is ampere. The battery has to supply the certain amount of current for 30 seconds at low temperature of minus 17 degrees Celsius. Okay, at the low temperature, and it has to supply a certain amount of current for 30 seconds. And the current amount is called cold cranking amps. So, for example, here, this battery, it says the CCA is 550. That means for this battery, we can use a 550 ampere current to discharge a battery at this temperature for 30 seconds. And the battery voltage can be higher than 1.2 volts per cell. You know, when we discharge a battery, the battery voltage will become lower and lower. However, the CCA means even though we use this high current to discharge a battery for 30 seconds at this low temperature, the battery voltage should be higher than this level. Then we can declare that the CCA of this battery is legless. Okay, that means if we use a 600 ampere current to discharge a battery, then after 30 seconds, the battery voltage will be lower than 1.2 volts per cell. Okay. Okay. Here are some summary about the lead acid battery. The lead acid battery is the most economical battery. It's the cheapest one. Okay. And for the larger power applications, where the weight is not so concerned, and the lead acid battery is a good choice. Okay, and the nominal voltage is 2 volts. It's medium voltage level, and the specific energy is 30 to 50 watt-hour per kilogram. It's low. The energy density is very low. The specific energy is low. The cycle life is 200 to 300. It's also medium, a little low. Okay, and the fast charge time is long. That means if we charge the lead acid battery, we have to use a lower C rate to charge a battery. However, we can discharge a battery at a higher C rate. The charge and discharge is not symmetrical for the lead acid battery. Okay. The tolerance of overcharge or over discharge is high. That means if you overcharge the battery, it's fine. There is no danger. There is no dangerous situation for the lead acid battery, even though you overcharge it, or you over discharge it. In our experience, we once do the experiment. We discharge the lead acid battery to 0 volt. It's fine. The battery is still alive. You can still use the battery. And in one experiment, we even discharge the battery to negative voltage. It's fine. So we just said that we can abuse the lead acid battery. We over discharge the battery, and it's fine. It's very robust. Okay. However, we also have to know lead, the PV itself is a toxic material, so the recycle should be careful. Okay, and the lower peak power ratings and less useful for applications that require brief high current is not possible. Okay, and here talk about the sealed lead acid battery. In the previous page, I have already discussed about the sealed lead acid battery, the SLA battery. Okay, this is commonly known as maintenance free because for this kind of battery, we don't have to replenish water. Okay, like the flooded one, we have to maintain the battery, but for this one, it is maintenance free. Yeah, there is no need to add the battery with water. Okay, and it has a similar construction and identical chemical reaction as flooded lead acid batteries. Okay. Yeah. The variation is we don't have to handle the gas loads. Okay, there are three kinds of SLA batteries here. They are commonly called bulb regulated lead acid battery. Like the previous page says, this is VRLA, and there are some battery called AGM. It is absorbent glass mat battery. That is there is a glass mat, and the electrolyte is attached to the mat. So the electrolyte is very closely attached to the positive and negative plates. And the third one is the gel type. The gel type means the electrolyte itself is a gel type. So for these kinds of battery, the mobility of the electrolyte is lower. Okay, because the gel type one is closely attached, and the number of cycle life for the gel type AGM and the flooded, the smallest is the flooded type. That is because for the flooded type, usually maintenance is very important. If the maintenance is not adequate, then the cycle life will be reduced. However, the gel type or AGM type, the cycle life may be longer. Okay, the comparison between the SLA and the flooded type. For the SLA batteries, it is maintenance free, and the installation in location requires that regular maintenance. Okay, so for the SLA batteries, usually it can be installed in some places that if the maintenance is not so easy. Okay. Maybe it is not easy to reach the spot, so we hope the maintenance is reduced. Okay, otherwise we have to pay a lot of effort to do the maintenance job. Okay, and the cycle life usually is longer. for the SLA because if compared to the poorly maintained flooded lead acid batteries, the cycle life is longer, and it can be placed on different orientation. That means we don't have to upright place the battery. We can put it horizontally. It's fine because electrolyte will not be leaked out of the battery. Okay, and for example, the AGM is immune to vibration. Vibration is fine. So on car or some factory machines, the vibration is very serious. For this SLA type is better for that kind of environment. And the AGM can tolerate operation in freezing temperature, in lower temperature. It is better than flooded type. The disadvantage here, the electrolyte cannot be tested by hydrometer. Hydrometer is to test the specific density of the electrolyte. The flooded type we can test the density with a hydrometer. So with the density we can know how much what is the SOC of the battery. But for SLA batteries, it is not possible. Okay, and the SLA is more expensive than flooded one. And yesterday they require ventilation, but less than the flooded lead acid batteries, and it is heavier. The SLA is heavier than the flooded type. Okay, and then the nickel cadmium. The nickel cadmium, the negative plate is cadmium, and the positive plate is nickel hydroxide. Okay, the chemicals. Actually, I'm not familiar with that kind of chemicals, but I do know that there is cadmium there, and the cadmium is a kind of toxic metal. So we have to recycle this kind of battery very carefully. And this is the chemical reaction, and the cell voltage is 1.32 volt. It's lower than the lead acid battery. That means the decomposition of the water is less important in this kind of battery because the voltage level is lower. Okay. The nickel cadmium battery is commercialized in around 1950s, so it is also has been used for a long time. The nominal voltage is only 1.2 volt, is lower. The specific energy is a little higher than the lead acid battery. The cycle life is longer, is much longer, and the fast charge time 1 hour is typical. That means we can charge the nickel cadmium battery with a higher C rate than lead acid, and the overcharge tolerance is moderate. That means we cannot like the lead acid battery to overcharge too loud, and the load current can be high, up to 20 C rate. And here is the charging curve. Okay, this curve is the pressure. So if the state of charge is higher, then you can expect the pressure inside the battery is higher. And this curve is temperature. Yes, the temperature is also higher if the SOC is higher. So under the charging process, you can expect the pressure and temperature will be higher and higher. And this is cell voltage. Okay, this is cell voltage. So basically, yes, we know as we charge the battery voltage will be higher and higher and higher. And here, this is 100% SOC. If we overcharge the battery, okay, if we overcharge the battery, you can observe that, yes, at first the battery voltage becomes higher, but then becomes lower. That means if we simply use CCCV charging method for the nickel cadmium battery, then maybe we will observe that after a minimum point of current, then the current will become higher, and then it might damage the battery. Okay, so this is a nickel cadmium battery. Okay, these kind of battery are mature and they have their moderate energy density, and the cycle life is much longer than others. The discharge rate can be high in extended temperature range, and the main applications are two-way radios, biomedical equipment, and the power tools. But uh, the application here listed here, that is when the lithium-ion battery are not so popular. Before lithium-ion batteries becomes popular, in the market, the nickel-cadmium battery occupies a lot of market, like the two-way radios. You can see some um, how to say that, the plane. You can some unmanned vehicles. They use a nickel cadmium battery as the power source in the old days, but now they are switched to lithium-ion batteries. Yes, and the cadmium is toxic metal, and nickel cadmium is notorious for its memory effect. Okay, so at that age, people will remind you that when you use a nickel cadmium battery, you have to discharge the battery until 0% of SOC. Otherwise, the capacity will be lower and lower and lower because of the memory effect. And then a newer type of the nickel series battery is invented. This is nickel metal hydride, or NIMH. You can find this kind of battery in shop. I think it's very easily to find this. This kind of battery is very similar to the nickel cadmium. Instead, the negative plate is different kinds of metals. Okay, and the cell voltage is 1.35. It's very similar. Only a little higher than the nickel cadmium. It is commercialized is in 1989. Is later than the nickel cadmium, and the specific energy is higher. Is also higher than nickel cadmium. The cycle life is shorter. Okay, so the NIMH battery has a higher energy density compared to the nickel cadmium at the expense of the reduced cycle life. The charging time is longer. That means the charging C rate is lower. The overcharge tolerance is low. It cannot afford overcharge. The load current is lower than the nickel cadmium. And there is no toxic metals, and there is no obvious memory effect for this kind of battery. Okay, then the lithium-ion batteries. In this figure, you can see the horizontal axis is specific energy density, and this is volumetric energy density. So the unit here is watt-hour per liter, and the unit here is watt-hour per kilogram. So if the watt-hour per kilogram is higher, that means it will occupy lighter weight, and the higher watt-hour per liter, that means the battery will occupy smaller size. We can expect that the lithium-ion battery has the highest specific energy, no matter in the weight or the volume. Okay, and then nickel metal hydride and nickel cadmium, and then the worst one is lead acid. Okay, so for the lithium-ion batteries, it is the fastest growing battery series. Now you can expect almost all the markets will be occupied by the lithium-ion battery, by these different kinds of lithium-ion batteries, and they offer high energy density. This is the most important one. They offer high energy density and the lightweight. Their energy density is much higher than other competitors, and partly it is because voltage level is higher. For the lithium-ion batteries, battery level may be 3.6 volt. And this is 3 times higher than the nickel cadmium or nickel metal hydride. And there is no memory effect for the lithium-ion batteries, and it needs very low maintenance requirement. Okay, so for the lithium-ion batteries, basically no maintenance is required, and the self-discharge rate is very low. Okay, 1.5 to 2% per month. Um, Yes, there is no toxic cadmium in the lithium-ion batteries, but the recycle is also important. But the recycle system is under construction now in many countries. Like in Taiwan, we don't have the system to recycle the lithium-ion batteries. It's under construction. Okay. But anyway, because there is no toxic cadmium, so the recycle is a little easier than the nickel cadmium batteries, and the protection circuit is required. That means for the lithium-ion batteries, it cannot afford overcharge or over discharge. We need a better protection circuit for the battery, for this kind of battery, to control the voltage and the current. And here it said for safety reasons. That means if you mistakenly use a battery, then there is danger. There is danger of the batteries. There is fire hazard, or maybe it will explode if you overcharge a battery too much. Okay, and then you can also heard that there is some lithium-ion polymer batteries. Okay, for the lithium-ion battery, lithium-ion polymer battery, basically they are the same. They are the same kind of batteries. It is also lithium-ion batteries, but for the lithium-ion polymer batteries, usually it is equipped with a pouch package. The pouch package means there is an aluminum foil outside of the battery pack, so it is soft. The package is soft, and so it can be packaged at different size, different shape. Okay, so this is a so-called lithium-ion polymer batteries. And then we will discuss about different kinds of lithium-ion batteries. Here we can see the LCO, LMO, and the MNC, and others. The C here means cobalt. So this is lithium cobalt oxide, and the M here is manganese. So this is lithium manganese oxide, and the N here means nickel. Okay, and the C also the cobalt, M also manganese, and this one LFP. The F here means iron, because you know the symbol for iron is Fe, so this F means iron, and the P means phosphor. Okay, so this is lithium iron phosphate batteries. Okay, and the NCA, the A means aluminum, and the LTO, the T means titanate. Okay, so there are many kinds of lithium-ion batteries, and we can see the battery voltage. They are around 3.6 to 3.8, but LFP, the lithium-ion phosphate, is a little lower. It's only 3.3, and the LTO, the lithium titanate, is even lower. It's only 2.4. Okay, you can notice this. The LTO has the lowest voltage level among all the lithium-ion batteries, and usually for other kinds they have 3.7, 3.6 volt. The cycle life. The cycle life for the LMO is the lowest, and for the LTO has the highest cycle life. Okay, and the specific energy. Specific energy for the NCA type or the NMC type, they are higher, and the LTO is very low. Okay, and the charge current here, most of them can be charged up to 1.C, but for LTO, the current C rate can be higher. And the discharge, again, for the LTO, the discharge current C rate can be higher. And for the LFP, the lithium iron phosphate, the discharge current can also be high. Okay, and the temperature, the LMO can be a higher temperature, but the high temperature does not mean that it can survive. It means it can, yes, you can use it at a higher temperature without fire hazard or the explosion hazard, but maybe the cycle life will be damaged under high temperature. And this is published here. The LCO is the earliest one, and the LTO is the latest one. Okay, if we charge the lithium-ion batteries, okay, again we use the CC and the CV to charge the battery. But after the charge is completed, it cannot be charged with a float charging. Okay, in the lead-acid battery, we can use float charging to keep on charging the battery, but for the lithium-ion battery, it is forbidden because the overcharge will cause a hazard of the battery. Okay, but after a few times, because of the self-discharge, so maybe you can occasionally topping up the charge with a small current. That is fine, but you cannot continuously charge the battery. Okay, for lithium cobalt oxide, the LCO, the negative plate, the negative plate here is graphite. This is graphite, the carbon. It is layered. The carbon or graphite is layered. And for the positive plate is lithium cobalt hydride oxide. It is also layered. And you can see the lithium iron. The lithium iron can be intercalated into the layer or intercalated out of the layer. Okay, so this is LCO batteries. The specific energy is around this number. Okay, until up to 190 watt-hour per kilogram, and the cycle life is medium, 500 to 1000. The overcharge tolerance is very low. Okay, so it cannot tolerate trickle charge, the float charge or trickle charge. The price of cobalt is high. Okay, the price is high. The cobalt itself is very expensive, so LCO battery is expensive. And the safety performance is poor. Okay, this kind of battery, the safety is not so safety. So you have to equip the protection circuit very carefully for this kind of battery. And then the LMO lithium manganese oxide. This is called the spinel crystal of the positive plate. The positive plate is this kind, and for the negative plate is the same as the LCO. The negative plate is also graphite. Okay. The specific energy is rounded stable, a little lower than LCO. The cycle life is also shorter. However, the load current level can be higher. Okay. The overcharge tolerance is also low. This is a good power battery. The power battery means it can discharge with large power, because you can see the load current can be high, so the power can be high, but that does not mean the energy level is high. They are different, you know. The power density and the energy density are not the same thing. High power density does not mean the energy density is also high. Okay, so for LMO, the power density is high, but the energy density is not so high. The stability and at low temperature is okay, but the high temperature performance is poor because the material, this kind of material itself is not stable at high temperature. And then I will talk about the NMC batteries. Okay, the NMC battery, there are three kinds of elements: the nickel, manganese, and the cobalt. Okay, this is called the NMC batteries. And there are also many kinds of NMC batteries. That is the percentage of the different element is they are not the same. For example, this 333, that means cobalt, nickel, and manganese, they occupy the same percentage. So this is 333, or officially called NMC 111. They share the same percentage. Or the 532. 532 means the percentage of nickel is 5, the manganese is 3, and the cobalt is 2. Or the NMC 811. So the nickel is 8, and the other 2 are only 1. Okay. Then, so basically you can see the percentage of nickel is higher and higher. Okay, so basically the nickel percentage higher, and the energy density, you can see the energy density for the higher nickel percentage actually is higher. Okay, so if we increase the percentage of the nickel, the energy density is also increased. And there is another kind of three kinds of element, or we call this ternary lithium batteries. There is another kind, it's called NCA. NCA means nickel, cobalt, and aluminum. And for this kind of battery, the energy density is also high. Okay. Generally, the nickel increase the activity of the material, so it will increase the energy density, and the manganese can enhance the material stability. So the incorporation of manganese will increase the cycle life of the batteries. Okay. And if we compare the LMO and the MNC, okay, for the LMO, there is no precious metal. The precious metal means the cobalt, because cobalt is expensive. And so LMO is lower price. The voltage level is like this compared to MNC here. And the volume density is lower. And for the MNC, the volume density is higher. So this is 3.6 gram per cubic centimeter, and this is only 3. The high temperature performance for the LMO is poor, and the cycle life is shorter. And for MNC, the high temperature performance is better, and the cycle life span is longer. For the NMC, for the NCA batteries, okay, MNC means this kind of chemicals. The percentage, the ratio is around 8 to 1.5 to 0.5. Okay, so similar to NMC, the NCA has a higher capacity and lower stability. Why we notice the NCA batteries? That is because the Tesla EV, they use a Panasonic 18650 battery, and that is NCA ternary material. Also, we notice this kind of battery. So at present, the NNC and the NCA are two popular ideas to solve the stability problems in the market. So most of the lithium batteries we found in the market are NMC and the NCA batteries. And here again, the manganese and the aluminum, they do not play the capacity role, they play the supporting role to provide a better stability to the battery. This is a lithium iron phosphate battery, LFP. The LFP battery is called, the shape is called olivine structure. For this kind of structure is very solid, it's very robust. So the cycle life for LFP is much longer than the other kind of lithium-ion batteries. But the mobility of the lithium ion is somewhat limited. Okay, so that means the internal resistance of the LFP is higher than other kinds of lithium-ion battery. Okay, here, what I said is listed here. If we compare the LFP with other ternary batteries, the energy density for the ternary battery is higher than the LFP. The safety, the LFP is better, and for the temperature performance, the ternary is better than the LFP, and cycle life, the LFP is better, and for the cost, the ternary is higher than LFP. That means LFP is cheaper. Okay, LFP cheaper. If you notice the news from the Tesla EV, the new Tesla EV, they turned to LFP batteries. Originally, they use NCA batteries, but now the new type of Tesla EV, they use